just to jump all the way back to where we started on Tuesday, remember that you've got an index right there, and then you've got a radicand, which is the number or the term under the radical, and then of course the radical itself. So that's the three parts that you'll hear me referencing throughout this video. Again, the index, the radicand, and the radical. So in the first example there, you see the index is 3. That tells me that I want to find a cube root of whatever the radicand is, which is -8. And so basically I need to know what goes in this expression. What to the third power gives me -8? And of course that answer would be -2. So the cube root of -8 is -2, and you don't have to write that part, just literally write -2 and you'll be fine. So continuing with that trend, if you want to take just a second and try that second one. If you need to pause the video, think about it for a second, go for it. Okay, so the fourth root of 16 would be 2. 2 to the fourth power is 16. The third one is x to the 12th, the square root of x to the 12th. You probably know this already, but just so we're on the same page, if you don't have an index listed here, we assume it to be 2. So this time we're looking for the square root. And so again, thinking about what squared will give you x to the 12th, well, that's x to the 6th. X to the 6th squared, or x to the 6th times x to the 6th, gives you x to the 12th. Next one, the fifth root of x to the 40th. And with this one, I'm going to show you the shortcut that some of your classmates figured out on Tuesday. Anytime you have a variable expression inside of the radical, so a variable expression is the radicand, basically divide the exponent of that, which in this example is 40, we divide that by the index, and that gives us the exponent of our answer. So 40 divided by 5 is 8. And then think about that, x to the 8th to the 5th, you would do 5 times 8 and get 40. So we're just sort of undoing that process. The next one there's the square root of 5y to the 10th. And this is sort of the review of the product rule for radicals, which says if you've got a product, which we do, 5 times y to the 10th, inside or as a radicand, you can actually split that product up like this. And why we want to do that is because we can actually simplify the variable part of that. Square root of y to the 10th is y to the 5th. But we can't simplify the square root of 5, so we just leave the square root of 5 under the radical. This is a good time to mention that we also typically want to write any part of that expression that's not under the radical, we want to write it in front of the radical. So that's why I put the y to the 5th over there and left the radical 5 over here. Next one, the cube root of 40. Can't take a cube root of 40, but I can take 40 and split it into 8 and 5. I can take the cube root of 8, that's 2, times the cube root of 5, which I can't do. So again, you want to use that product rule to split those apart because parts of them can be simplified. Alright, so jumping back in to the next example in this section, we're going to continue that talk of the product rule here. I can't take the square root of 20, I can't take the square root of x to the 3rd, but I can actually split that and into 2 separate radicals. The first radical, I want to put everything under there that can simplify, or that I can take the square root of, and then everything that I can't take the square root of, I'll put in the other radical. So think about the number first, 20. I'm going to split 20 into 4 times 5, because I can take the square root of 4, can't take the square root of 5. And then the x to the 3rd, if that were x to the 2nd, I could do it, right? Because 2 divided by 2 is 1. So I can actually split that into x squared times x. X squared times x is x to the 3rd. So if I split it like that, then I can take the square root of 4x squared, that's just 2x, and then leave the square root of 5x. So basically we're just taking those things that we did in class on Tuesday, the things that we just reviewed, and kind of putting all those ideas together. That's what this example is all about. So again, B, cube root, if I split that apart, 8 and 5 for the numbers, and then 3 won't go into 8, but it'll go into 6. So I can put 6 of those a's, or 8 of the 6th there, and then a squared in the other radical. And then cube root of 8a to the 6th is 2a squared, and then times the cube root of 5a squared. Okay, for this next one, fourth root, I'm just going to go ahead and assume that I'm doing this somehow. Fourth root of 48 I can't do, but I can split 48 into 16 and 3. And then I can do the fourth root of a to the fourth, so I'm going to put the whole a to the fourth thing under the first one. B to the 11th I can't take the fourth root of, but I can take the fourth root of b to the 8th. So I'll put b to the 8th there, and then b to the 3rd over here. So fourth root of all that is going to be 2ab squared, and then times the fourth root of 3b to the 3rd. Last one, fifth root of w to the 7th. I can take the fifth root of w to the 5th, and then that'll leave the fifth root of w squared. So that'll be w times the fifth root of w squared. Pause if you need to. Take a look at them again. Okay, so as part of this video, you're basically going to complete your quiz, and it's going to be a take-home quiz. Here's the first 4 questions on the quiz. So actually, I'd rather you not label them or number them A through D. I'd rather you number them 1 through 4. So just call this number 1, this number 2, this number 3, and this number 4. And on a separate sheet of paper, just go ahead and hit pause on the video. Take your time, go through these, look through the examples in the book if you need to. Try to complete those 4 problems. So go ahead and hit pause now. Alright, our next example is dealing with what is called the quotient rule for radicals. And the quotient rule can be interpreted in 2 different ways. And you're going to see both of those in these 4 examples. Actually, going to see both of those in the first 2 examples we do right now. So the first example, you've got the square root of 25 over 9. It's possible for us to simplify that fraction in there if it simplifies, but 25 over 9 doesn't. 9 will go into 25 evenly. You could probably turn it into a mixed number if you wanted, but there'd be no real reason to do that here. What we want to try to do is simplify this, and this quotient rule says that if it benefits us, we can treat that fraction under the radical as 2 separate radicals. So square root of 25 over the square root of 9. And those 2 things actually both are perfect squares, so that we can take the square root of both of them. Square root of 25 is 5, square root of 9 is 3, and so we can simplify that down to 5/3 using the quotient rule. If we look at example B, it's sort of the opposite. I can't take the square root of 15, I can't take the square root of 3. However, the quotient rule also works the other way, where I can turn that back into a single radical, and then I can do 15 divided by 3, because 3 does go into 15 5 times. So I can simplify that radical down to the square root of 5. Next one, cube root of b over 125. In its current form, can't do anything with it, but quotient rule says I can treat it like this. And while I can't take the cube root of b, I can take the cube root of 125, and that's 5. Looking back, I realize that that looks like 3 times the square root of b, as opposed to the cube root of b. There we go. All right. And then that last one, again, in its current form, can't do anything because can't divide x's and y's. But I can write it as a cube root of x to the 21st over cube root of y to the 6th. And then I can individually take the cube root of those. That'll give me x to the 7th over y squared. All right, second part of your sort of take-home quiz thing. Here's problems 5, 6, 7, and 8. So just on that same separate sheet of paper, go ahead and work out those 4. Look back at the examples that we've used. Feel free to rewind this video, go back and watch those again if you need them, and work your way through these 4 problems. All right, so this example is showing using both of the rules sort of at the same time. So example A, there we've got a fraction under a radical. Can't simplify the fraction, but I can write that as radical or square root of 50 over the square root of 49. Square root of 49 I can do straight away is 7, right? Square root of 50 I can't do anything with it yet, but I can break it apart into the square root of 25 and the square root of 2, and I can do the square root of 25. So that'll give me 5 times the square root of 2 over 7. So again, we're just looking to try to simplify, make the numbers smaller, make these things look simpler. All right, example B, we're dealing with cube roots. So the cube root of x to the 5th over the cube root of 8. So again, cube root of 8 is going to be 2 on the top. I need to put 3 of those over there and the other 2 over there. Cube root of x to the 3rd is x. So that simplifies out like that. So again, it's just putting those 2 things together, dealing with the quotient rule first, and then you end up using the product rule here. All right, next one. Same deal. Going to go ahead and combine a couple of steps on this one just to show you how to be a little more efficient. So a to the 4th goes there, the other a goes there. 4th root of a to the 4th is a, and the 4th root of b to the 8th is b squared. So there it is. Okay, this is it, folks. Questions 9, 10, and 11 for your little homework quiz assignment. Don't forget, you still do have a regular homework assignment in addition to these problems that you need to complete. And you'll need to bring both of those things, both of the questions that you did with this video as well as the homework questions. You'll need to bring those and turn them in on Tuesday. On Tuesday, we'll take an in-class quiz that will cover all of the material from this week. So both what we did on Tuesday and what was in this video will be on that quiz. It'll still be about 5 questions, sort of standard issue quiz, but it could cover material from both days. And then we'll jump into the next section and go from there. And that's it. So thank you for watching. I hope you have a great, safe, happy, enjoyable Hillbilly days and a little bit of time off from class. And I'll see you guys next week.